All right, guys, good morning. Happy snow day. We are going to finish our 7.4 notes today. And so I wanted to go through those with you. Be sure you're copying these into your packets. If you forgot to bring your packet home or if you left it at school thinking we were going to be there today, just write this down on a piece of paper and you can copy it down later. All right, let's let's start here with a warm-up question. This says a restaurant needs to build a wheelchair ramp for its customers. The angle of elevation for a ramp is recommended to be 5 degrees. If the vertical distance from the sidewalk to the front door is 2 feet, what is the horizontal distance that the ramp will take up? And that's labeled as X here. How long will the ramp be? And that's going to be the Y. All right, so they drew a picture for us. We have our 5-degree angle down here, and it's going to go up 2 feet. So it looks like the entrance to that restaurant is 2 feet higher than the street level. Okay, and then it wants us to find X and Y. So if you take away the words, you can just look at the triangle and find X and Y using our trig functions. Now let's start with X first, since that comes first in the alphabet. And let's see, what do we have? Compared to the 5 degrees over here, compare this angle, we have our opposite leg and our adjacent leg. And opposite and adjacent, if you think SOHCAHTOA, write that out over here, SOHCAHTOA. Well, opposite and adjacent come after the T, the O, and the A, so we're going to use tangent to find X. So we'll say tangent of 5 degrees equals the opposite 2 over the adjacent X. Okay, this is one of those tricky ones where we have to multiply both sides times X to get the X out of our denominator on the right side. That leaves us with X times the tangent of 5 equals 2. Okay, so I have to divide by the tangent of 5 on both sides of my equal sign. And when I do that, the tangent of 5s will cancel on the left side, giving me X equals, and then in the calculator you can type in just 2 divided by tangent of 5, and that's 22.8. And it looks like they want us to round in there as 10th. So yeah, 22.86, which actually rounds to be 22.9. 22.9, and they had this in feet, so we can put ours in feet as well. All right, that's X, but we also have to find Y on this one. I'll switch colors to do that. Okay, again, back to our triangle. Compared to the 5 degrees, the Y is our hypotenuse now, right? It's across from our right angle. And then we also have this 2 that was given to us in the beginning. So let's use the Y and the 2. That's going to be our opposite and our hypotenuse, O and H, which is sine. So we'll have sine of 5 equals the opposite 2 over the hypotenuse Y. Same idea as the other one. It's going to multiply both sides times Y to cancel them on the right. That leaves me with Y sine of 5 equals 2. Divide by sine of 5. Do it to both sides. Divide by sine of 5, and those are going to cancel on the left. And again, in the calculator, we can do 2 divided by, this time, sine of 5. And that gives us 22.947, or again, 22.9. Now, those look almost identical for the answers because we rounded. However, if you remember back to the other one, it was 22.86. If I write this out, 22.86, and this one is 22.947. Okay, and so the reason I'm showing you this is because our hypotenuse always has to be the longest side, and it is here, but because we rounded, they look the same. All right, so just be a little bit careful with that. And part of that is because this angle that we use is so small. 5 degrees is not very much at all. All right, let's go on then. We're going to talk a little bit about angle of elevation and angle of depression. So in your notes, I think you have to fill in the underlined words. And this says that the angle of elevation is the angle measure from the horizon to your line of sight when you look upwards. Okay, so when it says horizon here, it means this dotted line if you look at the picture. So it's from that one to the angle you make when you look upwards. So if we're looking at the airplane from this watchtower, it would be angle 1. That's the angle of elevation. You can pause and write these down if I'm going too fast. Okay, the angle of depression is the angle measure from the horizon to your line of sight when you're looking downwards. So this would be like the person in the airplane. Again, here the horizon, just like if you look straight off in the distance or a dotted line, but now this time it's up above. And when you look down, you make an angle of depression. Depression, things go down, like the Great Depression. Okay, and so that'd be angle 2 in this case. That's the angle of depression. One thing you'll notice, those angles are the same. Okay, because the horizon, whether you look straight off in the distance here or straight off in the distance there, those are parallel lines. And so that makes 1 and 2 alternate interior angles. Okay, so just kind of keep that in mind that those are parallel. Okay, so we're going to use that now. This says an inquisitive, this is number 2 in your notes, an inquisitive math student is standing 25 feet from the base of the Washington Monument. The angle of elevation from her horizontal line of sight is 87.4 degrees. If her eye height, so the distance from the ground to like her eye, is 5 feet, how tall is the monument? It says draw a picture. So I drew a picture here. Washington Monument is that, I think it's called an obelisk. Don't quote me on that. And if we make a right triangle, I drew one earlier, we're going to put it so it's lined up as a right angle from the base to the top. Okay, and it has this person standing over here at the other side of the right angle. Excuse my stick figure. And what does it say? It says the angle of elevation from her horizontal line of sight, and you know what? I think she is actually, this is going from her eye, right? It's at her eye height, so she's looking this way. This is 87.4 degrees. So this right here is 87.4 degrees. Again, definitely not drawn to scale, so excuse me for that. And then also we have to take into account that the distance from her eye right here to the ground, that distance is 5 feet. So we're going to use that at the very end. And it says, how tall is the monument? Okay, so first off, we want to know from her eye height, 5 feet up the monument, how far is the rest of it? How far is this side of the right triangle? Okay, well, compared to, let's see, I think I missed a part here. She's standing here. She's standing 25 feet from the base, so this is 25. So compared to the 87.4 degrees, the x and the 25 are going to be our opposite and our adjacent side. Again, go back to SOHCAHTOA, that's going to be tangent. We can say tangent of 87.4 degrees is equal to x over 25. X over 25. So for this one, I'm going to multiply both sides times 25. This is one you can do right in the calculator. In fact, I typically write out this next step, but you can just type this in. You don't have to write out that next step if you don't want to. In the calculator, you're going to do 25 times tangent of 87.4, which is 550.5 if I round, 550.5. Okay, that equals x. But the one thing that we forgot is that her eye height is 5 foot tall. Okay, so I actually have to add in, this one's kind of tricky and weird. I have to add in 5 more feet here, 5.0 if you want to think of it that way. And that will be the total height of the monument. Because currently, if she's just looking straight at the monument, right, I should probably extend this, because the base is actually 5 more feet down. When she looks straight at it, her eye, the horizon of her eye goes 5 feet up on the monument. So this is 555.5 feet. Okay, and I want to say that's true. I think it's actually 555 even, the Washington Monument. You can look that up if you'd like. Okay, number 3, this is a different one. It says a 25-foot tall flagpole casts a 42-foot shadow. What is the angle that hits the sun, or that the sun hits the flagpole? It says draw a picture. Okay, so I have my right triangle here. Let's see if I can match it up and make it a little bigger. Let's see if that works. works a little too big. And anyway, what this is going to do, there we go. What this is going to do is the sun is up here. All right, if I do this, all right, here's my sun. Okay, and it's casting a shadow down this line, and we want to know the angle that that sun is hitting at. So we have to fill in the other parts first before we can do this. And it says a 25-foot tall flagpole. So we know this side is 25 feet tall. It also says it casts a 42-foot shadow. So is that the diagonal line or is that the bottom line? Well, that's going to be the bottom line, right? Shadows go across the ground. If you were to draw the shadow of this flagpole, it would be on the ground. And it was 40, I made my picture too big. It was 42 feet, okay? 42 feet. Of course, as long as they put it in right, there should be a right angle. So it says, what is the angle that the sun hits the flagpole? Well, where is the sun hitting the flagpole? It's going to be this angle up here. Okay, that's what we're trying to find, is that angle up there. So again, compared to this angle up here, I might just call it A. Doesn't matter what you call it. Compared to that angle, we have our opposite side and our adjacent side. Again, another tangent one. You're finding we use tangent quite a bit. So we're going to say tangent of A equals the opposite 42 over the adjacent 25. Now, how do I find A, right? I have both of these numbers. Well, this is going to be the inverse tangent. We're going to say A equals the inverse tangent. That's with the -1 up above. And then in the calculator, it's the inverse tangent of 42 over 25. Okay, so let's see what that is. Second tangent of 42 divided by 25. And it's 59.237. 59 points. Does it want us to round? It doesn't say anything about rounding. Let's round to the nearest 10th. 59.2. And it says degrees this time because it is the angle. Okay, 59.2. If it wanted the other angle, remember we could take 180 and subtract our 90 degree and our 59.2, and that would give us what is left. Probably be, let's see, 30.8, I think is what that would be. Okay, one last one here. It says Elise is standing on top of a 50-foot building, and she sees her friend Molly. If Molly is 30 feet away from the base of the building, what is the angle of depression from Elise to Molly's feet? Okay, and they use feet here because they want to go all the way to the ground. Elise's eye height is 4.5 feet. Okay, it says draw a picture. So a couple things that's happening here. Again, Elise is the one looking. And I think this is Elise. I'll put an E there, and this is Molly down below. And so it says the building is 50 feet tall, and her eye height is 4.5. Okay, so from here to here is 4.5. That's from her feet to her eyes, and she's looking. Remember, wherever we look, that's what's making the angle. And then from the bottom of her feet is the top of the building, so from there to the ground is 50 more feet. Okay, and then Molly is 30 feet away. And so what we want to do is find, it says, what's the angle depression from Elise to Molly's feet? And if she's the one looking, it's from her eyes to her feet. I know it gets a bit tricky with the eyes and the feet thing. But what we're going to need to do is call this whole length, I'll do it in green. This whole length right here, we're going to have to call that 54.5. Add the 50 and the 4.5. 54.5. Okay. All right, and so we want to know the angle of, let's say, the angle of depression. So we have to think back to our slide. Let me go back over here to see angle of depression. Well, that's if the person who's up above is looking straight off and then down. It's the angle that makes it right there. So we go back to Elise and Molly. If Elise looks straight off in the distance, it's like, wait a minute, that's not even in the triangle. But what we can do is if I drop another altitude straight down, okay, I have another right triangle right here. Okay, this kind of top triangle. And then the angle of depression is going to be this one. Now that is the same as this one, so if you want to just find that, you could, but I'm going to do it up here at the top one. It's the same idea, right? If this is 30 feet, if this is 30 feet, this is also 30 feet. If this is 54.5, this is also 54.5. And then compared to this angle of depression right here, the 54.5 is the opposite. The 30 is the adjacent. So again, we're using tangent. We can say tangent of that angle, I'm going to call it angle A. Tangent of A equals 54.5 divided by 30, or A equals the inverse tangent of 54.5 divided by 30. In the calculator, let's go inverse tangent of 54.5 divided by 30. And that is 61.16 or 61.2. If we round, 61.2 degrees is what A would be. Okay, so its angle of elevation is 61.2. Now, that is the same, since they're alternate interior angles, as this angle, 61.2. Okay, so those would be the exact same, but it just asks for one of them, and that's the angle of depression, 61.2. All right, guys, that finishes out your notes. Hopefully you got those all taken. Remember, you can pause if you need to, or go back if I was going too fast. You can fast forward if I was going too slow. But a couple things is be sure you get those copied into your notes, and then also be sure you get all of this week's geometry assignments completed. Nothing new today besides taking these notes. Okay, so you've had a few days to do each of those assignments. It is expected that they're done by their due date. They are not going to be extended since you've had time to work on those, and that due date is tonight at 11:55 p.m. Enjoy the rest of your snow day.